it's Tuesday. I haven't seen you guys in a while, so I can go back to this. All right, there's a Spanish hacking group doing hacking of IP version 6, and it's very cute stuff. This one here, for example, is Snort. And I think in this class, let me interrupt you folks there. So Snort is coming up in this class. I think you'll set it up. And I'm going to make this bigger. Here. So you'll be doing this, in fact, in this class. You set up Snort, and then you scan that thing with Nmap. And Snort tells you you've got an Nmap scan coming in. It will detect it. Here's the scanner IP range. The picture we get with the version of Snort in your project here looks a little bigger. That's the point. But IP version 6 has the ability to add unnecessary headers at the start of every packet. You can put quite a few of them in. They call them extension headers, and they serve various purposes, but you can put them in even having them empty. So they do nothing, but what they do is confuse Snort. So what this guy did was he wrote a scanning tool, puts in front of Nmap that just adds some of those headers, and now when you scan, Nmap doesn't detect it at all. This is true of a lot of security appliances. Hey there, if you want to start your quiz now, you can just go in there, it's ready to go. Anyway, that's a fun thing to know. The Spanish hacking group is doing great stuff with IP version 6, and they will be presenting it at DEF CON, I think. A lot of it's on their blog. Firefox has decided to take the controversial step in version 22. Version 20 is what's out now. 22 is going through, I think, a 12-week process of like some beta testing before it comes out. And then it's going to have automatic third-party cookie blocking. So this is the big issue. Every company that relies on advertising, primarily Google, is surviving entirely on these third-party cookies. Microsoft wants to block them. If they could do that, that would take away Google's air supply, which is what they want to do. That's how they killed Netscape. So anyway, Firefox is on their own blocking them, so that will make Google hate them, which is a mighty strange thing for Firefox to do since 99% of their funding comes from Google. So if they do manage to punch Google in the eye, I think they might not appreciate the consequences. It is kind of odd. It's not surprising that Microsoft takes this position, but it is kind of strange that Firefox takes this position, and we will see what happens. I wouldn't be surprised if they have to secretly have some kind of exception for Google or something. What's that?
I think it's cool that they're punching Google in that section.
Well, it's kind of strange. They won't be there after Google pulls their funding.
I know, but Google needs to.
Well, that's what's probably going to happen. Google's probably going to have an antitrust lawsuit. They've been flying real high, and they have become a monopoly of advertising. So they're eligible for an antitrust lawsuit probably. Anyway, so terabyte SSDs are now up to a terabyte for $600, which is getting to be a pretty good price. Not quite as cheap as hard drives, but getting close. And when they are, then hard drives will begin to become extinct. A lot of people are switching to SSDs, even in data centers. One thing worth mentioning is that RAIDs are on the way out. Microsoft pointed this out a couple of years ago, and they've invented a new resilient file system called, I think, REFS to replace NTFS. Because the problem is, if I have like a terabyte drive, and I have a RAID with 5 terabyte drives, if I detect an error on one of them, I'm going to have to rebuild that whole drive, and that's a complete waste of time. Also, RAIDs are designed to handle failure of one drive. They're not designed to handle single spot failures on each drive. That's another issue. So what Microsoft has developed is a new system that has like little slices of redundancy all over the place, not a whole disk of redundancy. So it can deal with small localized errors better. And they have some mathematics arguing that RAIDs are not cost effective anymore with modern hard drive sizes. You waste far too much time rebuilding data that was perfectly fine because of one small error. Yeah?
Is he going to come with Windows 9?
Yes, I think it's already out with Windows 8. But it's not going to be on your client. It's just used for multiple disk arrays. Yeah, that's right. They were going to have a new client file system called WinFS, but they just decided to abandon that. They're going to stick with NTFS on the client. But your servers will have this new file system, and it's already out. I thought this is pretty cute. I hadn't thought of this. This is actually very clever, and you can trivially write it yourself with a bash shell script. This is a way to detect if your website gets breached. It just loads your website, and it counts the number of embed, iframe, meta, and script tags, because those are tags that you don't use very often in your normal page, but those are the tags that bad guys use to inject code in your page. So you probably have a few of these in your page, but it just notices when that number changes and then sends you a message. It looks like you just got hacked. Either you just upgraded the version of your page and made drastic changes. If you didn't, somebody just injected an iframe with code, which happens a lot. So it's pretty cute, and you don't need any permission.
That's sort of baseline before you do that?
Yeah, you turn it on, it makes a baseline of what you got now, and just saves it, and then notices when it changed. I mean, you could write this in like 20 lines of bash yourself. But they'll do it for you and just send you an email. It's very cute. So you obviously don't need permission from anybody to do this. Don't need a password. It's a pretty clever idea. So I think my CSSP students should set up one of these, scanning the college website. We're working on that. And this one's cute. You might even put it in this class where you play with Windows Credential Editor. Let me check. I think down here in the extra credit projects, I put in one where stealing login passwords remotely. This project here is pretty awesome. I was thrilled to hear this. What you do is you log in with a login account with a really long password. Put in something like 30 characters long. There's no way you can ever crack that hash or ever guess that password or anything, and it doesn't do a bit of good, because if you take over the machine with a remote control exploit, like a Java exploit, that's what I usually use because Java is a piece of junk and it's easy to take over any machine that has Java on it. So if you take over the machine with Java, you can then run this product called Windows Credential Editor, and it will just read the password right out of RAM, no matter how long it is. So the currently logged in user's password there, bypass UAC, and then you get the password right there. You get your name, that's the account, and I think this is the password. Your name 123456090. That's the long password. So this is currently done by accessing a file that you have to upload to the other machine. There's two versions. Originally a tool called Mimikatz, written by some French hackers, and then a tool called Windows Credential Editor, written by somebody in America. But in both cases, you have to move an executable up to the victim and run it there. And so this new technique here does it all in RAM. So it's even nicer. So I'm probably going to write this up as another project. This is very nice. You use Metasploit, which is in Backtrack, and you'll use it a couple times in this class and a lot in the hacking class. And you can get the passwords right out of RAM, which is very nice. So we'll see. That should be a lot of fun. And a couple of British Anon just pled guilty. There's a problem with the law, which is why these guys like LulzSec people go. They're generally young and sort of mentally unstable, and they will like hack Sony and hack the FBI, and nothing happens, and they say, we got away with it. Well, what happens is it takes years to prosecute people. So this guy was part of the gang that hacked into the Serious Organized Crime Agency, which is like the FBI in Britain, and the National NHS in Britain, which is their health service, and a bunch of other people. And he did it, I think, in 2011. So here it is, 2013, now he's in court. So it takes 2 years to get caught, and people don't think on that time scale, so they do something, next week nothing happens, so they do it again. Next month nothing happens, they say, this is great, just hack everybody. They don't realize they're building up a big debt that they're going to have to pay later. But anyway, most of them are pleading guilty over in Britain, which is saving everybody a lot of bother with the trial. Anyway, I owe you folks a quiz, I guess. All right, so if I tell you that we're using Windows, and they might get viruses, what's that? It's a vulnerability. We're using system that's a vulnerability. We are weak in that regard. By using Windows machines, we are vulnerable. It's not a risk because it's not measured. It's not got a numerical amount of loss. Right, and it's not right. And the way it's phrased here, it's a vulnerability, not a threat, because it says we use Windows machines which are more susceptible to viruses than OS 10. We'll get to a threat. So we have campus police. What are they? They're mitigation. They lower risk. So if certain bad things happen, the police will step in and prevent them, and that's good. Mostly parking, but anyway. So students might steal computers. What's that? That's a threat. That is a bad thing that might happen, and no statement here about how often it's going to happen or how likely it is to happen. It's just something to be worried about. If vandalism will cost us $1 million a year, what's that? That's a risk. It's been measured and turned into a number. So it's a threat that has had added to it more information, so now you can do better planning based on it, because now you know how much you're going to lose due to vandalism, and you can then decide whether it's worth paying for some kind of defense to prevent it. All right, if we have cheap blocks that are easy to pick, what's that?
Vulnerability.
That's a vulnerability. Like the Windows machines, they are weak, some threat could get through. And if deep freeze removes the program students put on, what's that? That's again a mitigation. Now we are protected from the students putting software we don't want on the machines. Okay. So what's the security assessment that finds a single way in and exploits it? That's a penetration test. Somebody breaks in like a crook. They find one way in. And some people say this is not worth doing. Brett Harding, in particular, spent years doing it. Now he's been giving talks at all security conferences saying penetration testing is stupid. But anyway, that's the way it is. Penetration testers break in, and you find one weak path through your network. All right, what's your rainbow table then?
Use the correct encrypted passwords.
What is it?
Encrypted passwords.
No.
List of hashes with long names.
I'm hearing parts of it over here. What's the list of hashes? Yeah?
List of hash,
Okay. Right here. Yeah.
well, list of hash marks with long names and instead of stored in the RAM, that's what.
Well, I'm getting part of it. Well, you got to cut here. Yeah.
It's a database of like 1 billion passwords with hashes on them?
That's closer. Yeah. Yeah?
Time memory trade-off.
Yeah, time memory trade-off. See, what it is, it's like a multiplication table. It's a mathematical table of inputs and hashes. Although if you really look into it in detail, it doesn't do the complete hashing process, it does part of it. But the point is, it just does, it's a bunch of the calculation previously done and stored in RAM. So it makes you faster by consuming more RAM. That's the time memory trade-off. It's a pre-computed list of hashes in RAM is one way to look at it. But it's a list of all possible hashes is what it is. A list of all possible passwords in their hashes or a mathematically similar object. All right, any other questions? All right.
27, April 27.
Yes, I'm pretty sure it is. In fact, let me check that. I'm glad you bring it up for the war driving. It's on my 123 page. Oh, what? Well, you kind of need at least 2 people on the device. But we'll have, yeah, it's April 27, yeah. If you have a laptop that can run Windows 7 or Linux, that's good. If you have a car, that's good. If you've got nothing, I'll have a certain amount of loaners available. Anyway, we'll drive around and... If you have a Mac, I think you're out of luck. As far as I know, there's no good war driving software on the Mac. Somebody might find one. We haven't found one for the last couple of years. Yeah?
What's the talk on today?
She's going to talk about her career, how she made it to be a security professional and what kind of training it took to get there, and answer questions from the students. That's the careers class. So we have various professionals coming in from the industry to guide students. It's kind of funny. I remember one guy was really popular. He told students college is worthless, degrees are worthless, just get out of here and get a job. They have their opinion, you know. You hear the opinions you don't get in school because you only get half the story here. And the cliche is you hire kids at a workplace and they say that new kid is fresh out of college. They think they know everything and they don't know how to do anything. So there's another whole half of getting ready for the job which you don't get from school. So this is my attempt to give you some of it. Anyway, yeah. A multi-use building, 330. Yeah, across Phelan. All right, anyway, so let's carry on with business continuity. So, bad things happen. You're going to have servers fail and drives fail and earthquakes and all that jazz. And so then if you are like most small businesses, you have no preparation for this at all. And if there's an earthquake and things fall down, you just go out of business and like apply for relief or something. But big businesses are not able to do that. Big businesses have to plan beyond that sort of thing, and that's why they survive. So the basic thing you do is you have redundancy. You have somehow secondary systems. I remember when I was a kid, this first came out with NASA. They were all excited when they said the NASA spaceships have 2 of everything or 3 of everything. So if one fails, they can go to the backup because it's not really good to be out in space and then some component is broken and you're just going to die. So you have some kind of duplicate systems where, what you're trying to do is be fault tolerant. This means a fault does not turn into a failure. A fault is when something stopped working. A failure is when your customers stop getting service. And if you have a server and you have a second server that takes over when the first server fails, then you survive the fault without having a failure because service continues to be provided to authorized users. That's what you want. So the most common example is RAID. If you have a single hard disk and it fails, your server goes down, so you put a cluster of disks together, redundant array of independent disks where you have 3 or 5 or some number of disks, and there's extra copies of the data on those disks, so even if one disk fails, the others can still deliver all the data to the user. That's how you survive the failure of a disk. Server redundancy, you have clusters, multiple servers, so if one server fails, another server can just take over the load, and you can do the same thing with power. In power, you don't usually have multiple power supplies running all the time. What you have is the line power, and when that fails, you have a battery, UPS, that gives you some period of time of power, and in that time, you have time to start your generator. That's how you have consistent power at places that really won't put up with power outages, like hospitals, where they're in the middle of surgery, And it's not okay that PG&E just went down. And there's also site redundancy for your business. You can just have an entire alternate site ready to go so you can abandon your whole building and go to another building and continue getting work done over there in case of like a flood or just a fire or something that destroys your whole building or makes it unusable for a period of time. Well, the basic point is you should not have a single point of failure anywhere. Look at your whole system. No one person should bring it to a stop, no one building, no one power supply. There should be nothing that you need that you don't have a spare or an alternative of. So it makes sure you have extra disk, extra servers, extra power, and then you will survive more faults. There is some level of disaster, of course, that will bring your business down. I mean, if the whole world is destroyed by nuclear war, your business will go down, but you have to have some limits. Nothing's ever perfect. So RAIDs are the classic one here. RAID 0 is a non-fault tolerant kind of RAID. RAID 0 puts 64 kilobytes on one disk and 64 kilobytes on the next disk. So you call it disk striping. And the point of this is it reads and writes fast, because if I write a file, it's writing chunks of that file to all the disks, so all the platters are spinning, all the read-write controllers are running, so I can write faster and read faster, but it's not fault tolerant. It doesn't make any extra copy of the data at any point. In fact, it's less reliable than a single drive, because if you have an array of 10 drives in RAID 0 and any one of the 10 drives fails, you lose your data. So you increase your chance of failure. Of course, think about RAM. You put data in RAM all the time, and if the power fails for even an instant, the RAM will fail. So you accept a high chance of failure in return for speed. And RAIDs are a way to make hard drive more like RAM. So you would not want to put your storage data, you're keeping your archival data for a long time in a RAID 0, but you would want to put something like a page file in RAID 0. Data that should have been in RAM anyway is put in RAID 0. This is what Microsoft recommends. For servers should have the page file on a striped array, because it's the fastest way to make a disk run, and it will give the best performance. RAID 1 is the first RAID form that's fault tolerant, and that's mirroring. It's the simplest and most expensive RAID. If you want a 500 gig drive, you have to buy two 500 gig drives, and every time you write twice. And so you have two identical copies of everything. This is what Microsoft recommends for the operating system drive on a high-performance server, so that if one drive fails, you can switch immediately to the other one and have the server continue to operate. That's the problem. This is if you use two disk controllers, they call it disk duplexing. With a single controller, it's called disk mirroring, but they're both RAID 1. You have two copies of all the data, just an exact identical copy on another drive. That's kind of wasteful, so the most popular one is RAID 5. RAID 5 makes extra copies of the data, but it doesn't make 100% extra copies. What it does is you'll have a block of maybe 3 drives, and you add an extra drive, a fourth drive, and it takes an exclusive OR function and combines the data on one drive with the next drive and the next drive and stores the result of exclusive ORing them together on the fourth drive. So what it means is if any one of the drives fails, it can take the remaining information and reconstruct the missing data. And it does this with a striped fashion so that redundancy information is mixed across all the different drives. And it turns out to be the sweet spot for most people. This way you don't waste a lot of money. So if you want to store 1.5 terabytes of data, you have to buy 4 500 gigabyte drives. You only lose 30% overhead. It depends, basically if you have n drives, only one of those drives is extra. And it can withstand failure of any one drive. When one drive fails in a RAID configuration, you do lose performance. Your drive will slow down, and when you replace that drive and put in a clean one, you will again lose performance as it spends time reconstructing all the data and rebuilding that drive. But you can have something like a web server that continues to provide service to clients all the time, even though one drive fails. So that's the game here, and they call that extra information parity. And there are other ways to mix these together. You can do a RAID 10, which is 2 RAID 5s that are mirrors. So you've got more extra copies of data, and you spent more money, but you're more fault tolerant. You can also have RAID configurations that let 2 drives fail, and you still don't lose data because they have extra parity. You can combine these in any combination you want. But ultimately, as any common sense would tell you, you have to have some extra copy of the data somewhere, or you're not going to survive when a drive fails. Hardware, yeah, go ahead.
You said they call RAID 5 something, and I think I
RAID 5, what?
Yeah, what do they call RAID 5?
I've never heard it called anything other than RAID 5. You can call it distributed parity, that's the technical term. So there's something called RAID 3, where you have one drive just to carry all that parity data. And that turns out to be slow, because every time you write to any one of the drives, you also have to write parity. So they took the parity and put stripes of it on every drive. So every drive has some parity and some plain data, and that way they're all equally reading and writing all the time. That makes them faster. So RAID 5 is almost as fast as a stripe and still fault tolerant. So it's the best answer for most people. Anyway, yeah, it doesn't have a word like the mirroring and striping. Yeah?
If one of the drives in RAID drive 5 fails,
Yeah.
what do you have to stop all of them?
No,
To
that's
replace it?
one of the drives fails, the system can still find all the data because it has one copy of all the data left, so it can still serve customers. Then you take out the broken drive and you put in a replacement and it rebuilds it. And all that time, customers are getting service. That's the point. This is how you have no downtime. Even though you have a fault of one component, you have no failure. The customers continue to get service all along. That's what you want.
Configuration required?
Well, yeah, that's actually getting right to here. See, usually people buy a hardware RAID. This is the easiest and the best kind. You buy a special box just to be the RAID, and you plug it into the computer. The computer does not even know it's a RAID. To the computer, it appears to be one SATA drive or something, or one SCSI drive. And the controller out here is a hardware controller, and it handles all the drives, and it's got lights on the front panel. They're all green. When one goes red, you know, and you just pull out the drive and you put in another without turning the power off or anything, hot swappable. That's what you want. And it automatically reconstructs the missing data. You can do it with software. Microsoft Windows can have multiple drives added to a Windows machine, and it will, in software, do all this parity calculation. But that way, you kind of defeated the whole point, because you can't pull a drive out of a Windows machine without turning the power off. So if your drive fails and you want to replace it, you have to have downtime, and the whole point of the RAID was to have no downtime. So software RAID is kind of for the birds, and I don't know anybody that does it that way. Hardware RAID is where it's at. You buy a RAID controller, hot swappable, as an external device, and then you just replace those drives when they fail. That's what everybody does. Anyway, but both of them are technically available. It's just software RAID is mostly just a stunt, as far as I can tell. So, in general, this is the gold standard everybody wants, so-called 5 nines. 99.999% up. This is what everybody wants. This is what everybody promises, and nobody delivers. There are only a couple of cases I've ever heard of anybody actually achieving this. This is really heroic. 5 nines means 5 minutes of downtime a year. That's really heroic. There's a 5 nines hosting center called 365 Main in San Francisco that promised 5 nines, and they went down for 2 days because their power supplies failed. Amazon, I don't know how many nines they promised. Amazon went down for 4 days. Cloudflare doesn't promise how many nines. They went down for 2 days. 6 months later, they went down for 20 minutes. You know, they went down for 2 hours and then 20 minutes. You know, being down for only 5 minutes, that's really heroic. There's one company I know that made it, Hartford Insurance in Texas. And they actually overbuilt by a factor of 6. They built 6 times more servers than they needed. They put them in 3 different towns, 200 miles apart. Each one of them had a whole swimming pool of like cooling water. And it was just ridiculous. You know, they spent like $10 million building stuff where they needed about $1 million worth of server, and they got 5 nines, and that's what it takes. Even when tornadoes came in and everything else, none of those servers stopped providing service, because there were copies of identical servers in. So you can do this, but it's quite painful. You got to have 2 or more servers. Now, if you have failover clusters, that means some of the servers are just sitting there waiting, doing nothing until this one fails, then they'll take over. That's one way to work. This is not easy to sell to management, because you say, I'm paying what? I'm paying twice as much money to get the same service. For why? Just in case something breaks. So that's questionable, but this is how a failover server works. You have 2 servers, and you have a heartbeat going from one to the other. There's some kind of pulse going back and forth saying, I'm still alive, okay, you're still alive, okay. When you stop getting the heartbeat, the other one takes over. Saying, okay, this guy seems to be dead, I better take over. This is what happened at City College several times. We have some failover systems here. And unfortunately, a fairly common fault around here is that one of the systems fails in that it stops providing service, but it continues to provide the heartbeat. So the other one does not take over. That's a problem. Things fail halfway. And then failover clusters aren't so brilliant. So load balancers are more popular. They're more complicated to set up, but management likes them better because none of your servers are just sitting there doing nothing. A load balancer means you have people from the internet coming in, you go to the load balancer, Barracuda sells them, it then sends stuff off to all the servers, and all the servers are working all the time. So when everything's working, you get high quality service. When one of them fails, the 3 remaining ones take over the service, and your service is a little bit slower, but you're not wasting your money on those servers. They're all working all the time. Yeah?
What if the load balancer fails?
If the load balancer fails, it's a single point of failure. So you have to consider that also, absolutely. So you might want to have 2 of them, or you'll have some other plan to go back to a non-redundant system if the load balancer fails. Exactly. Yeah, it's just the right way to think. You add a new component, you might just be creating another single point of failure. Anyway, so scalability is a general feature of any network where it can easily expand. So as your business grows and you want more, you can just add more without having to reconfigure everything. That's what you want. There are different ways for load balancers to work. One simple kind of load balancing is round robin, where it just says the first customer goes to this one, next customer goes to that one, next customer goes to that one, next customer goes to that one. This will keep them all busy and approximately equal loaded. If all your customers require equal amount of work, it's fine, but of course not every web page is the same, so that's kind of sloppy, but it's easy for to make a load balancer do that. That's round robin, simplest kind of load balancing. A better kind is equal workload balancing is more difficult to set up, where it actually monitors, polls the servers saying, how busy are you? I'll take the one that's not so busy and send it the next request. That way they all stay up to approximately the same amount of use. Anyway, the load balancer will detect when a server fails and send the traffic to the other servers. I mentioned this before, UPS, uninterruptible power supply, is just a battery system. So it's got enough power to power your devices for some small period of time, like 5 or 10 or 15 minutes. And therefore you have enough time to either send out a message, the server is going down, save your work, or turn on your generator, depending on whether you're decided to completely avoid going down or you've decided to just avoid breaking your server because UPS keeps cutting on and off. So that's the point. You can shut down cleanly, or you have time to wait to start your generator or commercial power to return if it does return after a short downtime. And if you have a generator, the typical thing you have is diesel. You have a diesel generator in the basement and a tank of diesel, and actually that gets some people concerned because that is a terrorism threat. You can blow up that tank of diesel. So you have another security balance to make between whether you want to store a lot of diesel on site so you can survive a long outage, or you want to have a small amount of diesel on site, and then if the roads are blocked, you can't get the truck in, so you have to make a decision. Yeah?
Have you ever been about companies using renewable energy as power generators?
I haven't heard many people talk about it. I think Google does that kind of thing, but most people, for disaster recovery, you just don't worry about it because you're not going to use it all the time anyway. For power used all the time, Google's the king of this. Google is very, very interested in environmental stuff. They get a lot of their power from solar and stuff. It's one of their things. They're very much focused on that. From the early days when they said, don't be evil, before they took that out of their motto, they were really into doing everything the eco-friendly, nice way. Then they went corporate, and they removed don't be evil from their policies. Well, you know, that's for amateurs. You're professional, evil is your business. And that's kind of the way it is, you know. So when you get big enough, no matter what you do, you're hurting somebody. So good and evil get a whole lot more complicated. So come get an eye clicker if you need one. All right. But I will protect you from a brief power outage. All right, and that's, of course, the UPS. Gives you a few minutes worth of power. All right. Get rid of that stuff. All right. A system that can easily grow. What's that? All right, that's scalable. Yep, everybody got that. All right. All right, 2 complete copies of every file. Which RAID does that? I think you're not going to like me. Nope, you aren't. E is the right answer. Because RAID 1 does it and RAID 10 does it. RAID 1 has 2 complete copies of everything, and RAID 10 has 2 RAID 5s and a whole other copy of the RAID 5. So both of these have 2 complete copies of every file. So you have to pay for twice as much disk as you're going to use, and in this case, even a little bit more. But in return, you're very fault tolerant. All right. So which of these will protect data when a hard drive fails? All right, now RAID is what specifically does that. If you wanted to be kind of picky, you could claim that a cluster of servers might do it too, but anyway, a RAID is the most directly answers the question. All right. So, backups. I remember when I first learned about RAIDs, I said, well, you don't need backups. There's another copy of the data, but they're totally different. See, a backup saves you if you lose the machine, like the whole building burns down, or you accidentally delete the file. Suppose you delete a file, the RAID deletes all the data off all the drives. Now what, smart guy? Now you're hosed. Your RAID is not going to save you. So backups are another issue. You have to have copies of the way the data was on previous days stored somewhere else. So if you lose everything, like the building burns down, your whole RAID is gone, you still have something. So this is just extra copies of your data. And you should store them off-site, not in the same building, in case the whole building is destroyed. So typically what you do is you write tapes or removable hard drives, and you have some system to take them off-site. Now amateur businesses, like small business I used to work at, would just give them to like a secretary or something to take them to the bank or something and put it in the safe deposit box. Several companies had huge scandals because somebody got their car stolen while the backup tape was in it, or someone stole the backup drive out of the back seat. And that stuff is typically unencrypted, and now you've exposed all your client's data. So I kept on trying to get people to encrypt their backups. I was never successful at convincing any of the businesses I dealt with to do that, but you really should encrypt your backup tapes. You think that's just trash, I won't even need that list as a problem, but if you lose it, you've got a big problem. Anyway, so you have backup someplace in case you lose your data. Then the most common thing is you accidentally erase data. That's the most common reason you need a backup. So you put it on something you can take away. Tape or hard disk are common because they write fast. You could back up on CDs or something, but it's not as common. There are different ways to do it. A full backup is a complete copy of all the data you want to back up, like everything on your servers. A differential backup is one that backs up only the data that has changed since the last full backup. So you do a full backup on Friday because you got the whole weekend. Then on Monday you do a differential backup at the end of the day, and Tuesday. Incremental backups are the smallest. They back up the data since the last backup. And that might have also been an incremental backup, so you might need to play Friday's tape and then Monday and then Tuesday and then Wednesday's tape to reconstruct the way it was on Wednesday. Anyway, all those are the techniques. The full backup is the most expensive and slowest. Yeah?
What is back? Are they using a differential or?
I think they're doing a new differential, yeah, the time machine, yeah. I think that's what's going on. We have that count, we have this data, that data, yeah. I'm pretty sure that, and if you do differential or incremental, you have to do a full backup periodically. I mean, small businesses, the ones I work at, just did full backups. They didn't mess around with any of this because our servers weren't very big. The backup would only take an hour or two. We just did it every night. And that's, of course, the simplest and the safest because you have everything on one tape. But if you have a huge drives and you don't have enough time to back them all up at an ordinary business night, then you do these complicated schemes. Differential is cheaper and faster than making a full backup every night, but it's going to take it might take 2 tapes to recover your data. You have to pay the last full backup and the differential backup from that date. And incremental backup is the cheapest of all and fastest, but you might have to play several tapes. And one thing that happens at companies, like the ones I was at, is you have a variety of people working in your server team, and the guy that is an idiot, that does everything wrong, that is out smoking pot on his break behind the trash can, is the guy they put on backup, because you don't want them doing something that's going to go to the client. So usually your backups are fouled up. Every time we go for them, they were labeled wrong. Half of them weren't actually done. The same tape was left in for 3 days in a row and stuff like that because you put the stupidest guy in your company on backup. So you have to test your backups. Every now and then recover something. There should be a periodic test like every month where you try to recover something from last week and make sure it's there, because you will very often find that your backup procedure failed a year ago and nobody noticed. Anyway, so that's important. Anyway, SimForm is a cute system. I went and heard about them at Pacific IT Pros. They had Dream at the last one talking about their backup system. SimForm is a BitTorrent kind of backup where you donate some room on your server and you're storing some data from other people. Everybody's data gets encrypted, stuck in a giant RAID sort of array with 96 pieces where you only need 64 of the pieces to reconstruct the data, stuck on 96 different servers. And if you want it, you can just download it back from those with their software. It's very nice. The problem is it has a single point of failure, which I didn't find out at their presentation. I figured it out about a year later. They run the whole thing from Amazon E2C virtual machines as the command and control server. So if Amazon goes down, SimForm is down. I contacted them, and they tried to avoid answering that question until I kind of figured that was my answer. I said, wait a minute, you really have a single point of failure in a disaster recovery system? Please tell me you don't. But they do. And on top of that, Amazon is hosting almost everybody anyway. So if Amazon goes down and you're counting on your SimForm backup, you're up the creek. Anyway, you can't have everything. It is a pretty clever idea. There's a lot of systems. So you got to put your backup someplace. Your backup is as valuable as your original data, so it should be encrypted and stored in a locked room and all that jazz. It should be transferred in a secure way. If you use Iron Mountain, they will send a armored car to your location to pick up the backup tapes, just like with money, because it is that important. And when you're done, you have to destroy your old backups, You don't want them anymore.
You just recycle it, you crush it, like you think it's recyclable.
Yeah, but you have to make sure and get all the data off it. So you erase it and crush it, yeah, that kind of thing. So Iron Mountain is a famous company for this. There's this truck they'll send to shred your paper right on site and burn the paper and pick up your backups and all that jazz. They handle these sort of things. They're considered relatively expensive, but they do good work. I got a student working over there. And so you have to have policies for your company to specify how you're going to do the backup. You've got to choose what data gets backed up. What you typically do at companies is you back up the data on the server and you do not back up the data on workstations like this. So if somebody puts a picture of their cat as their background and their machine fails, you just ruthlessly replace the hard drive and get it back to a standard hard drive and that never gets backed up. Anything company related goes on the server and that gets backed up. That's typically how you do it because these end stations are too hard to recover data from and people can mess them up easily. You have some kind of offsite storage. You have to label everything so you know what all the backup tapes are, and you'd specify how long you're going to retain data and when you're going to destroy it. I remember this was a big issue at my old escrow agency. We didn't have a clear retention policy. Stuff was just piling up forever, but we had warehouses full of it, and that got to be kind of a problem when we handled the Vieira case. There was a guy named Vieira. Vieira's flying mortuary that would scatter the ashes of your loved ones in the bay. He ran for 10 years. He never actually got the airplane or scattered any of the ashes. He was just piling them in a barn. When they found out he killed himself, and we were the escrow agency that got the case to return the cremated remains to the loved ones. And a large portion of them were destroyed or otherwise impossible to return. So now we had boxes full of ashes in with our tapes, in with our old papers, and no clear instructions from the court as to how long we have to retain them. But anyway, that was one of our crazier cases. Anyway, so if you want to prevent downtime when a component fails, which one of these will do that? All right, that's fault tolerance. Fault tolerance is to avoid downtime. So even though something fails, you continue to provide service. Which of these will protect your data even if your location burns down? All right, and that's of course why you have to have offsite storage. You've got to have your backups. So backups are for disaster recovery. Fault tolerance is to avoid downtime. Those are different goals, and neither one of them replaces the other. If you don't have a RAID, you'll have more downtime, even though you might have a backup. If you don't have a backup, you'll be in trouble in a disaster, even though you had a RAID. All right, so which system uses the least time and tape? So incremental uses the least tape to create it, but the most difficulty getting it back.